Hello children, the continuation of work energy, that kinetic energy. See, the kinetic energy, which is nothing but a moving object, is capable of doing work because of its work or because of its motion, we can say. See, the energy which it possesses by virtue of its motion, and it measured by the amount of work that the object can do against an opposing force before it comes to rest. And kinetic energy, we can say a moving object can do work, and an object moving faster can do more work than an ideal object moving relatively slow. A moving bullet, or for example you can take a blowing wind or rotating wheel, like some of the examples, just imagine how does a bullet piercing the target, how does the wind move the blades of a windmill. So objects in motion possess energy, so we call this as a kinetic energy. And some of the examples we can see, the bodies which are possessing kinetic energy. For example, a ball rolling on a surface, due to it can set another ball into motion by striking it. Is it right? A bullet fired from a gun is able to penetrate some distance into the target which it strikes. And a moving hammer, the moving hammer, obviously we know that. And the falling body as it can break something on which it falls, or maybe, right? So this is the falling body. And the moving hammer, that it drives a nail into the wall against the resistance which offered by the wall. So these are all the energy which transfer. It is the moving things. So the expression for the kinetic energy we can say. So you can consider an object of mass m which is moving with an initial velocity u on a perfectly frictionless surface. Now we can let us consider a constant external force also, that is F, which is act on it, and it is produce an acceleration A, right? So if suppose we have taken u is the initial velocity, we have taken that v as the final velocity of the object after having undergone a distance s. Then we know that applying that formula, a v square minus u square which is equal to 2as, or the distance s which is equal to, or we can say here displacement s which is equal to v square minus u square by 2a. We can take this as a first equation. And what is work done? We know that the work done by the force in displacing the body, then W which is equal to Fs, and we can keep this equation as second equation. And now we can move on to that, the Newton's second law of motion. What is Newton's second law of motion? F which is equal to ma. So W which is equal to, we can apply the force value here, ma into s, we got it, that is v square minus u square by 2a. So by simplifying it, we got m into v square minus u square by 2. So W which is equal to half mv square minus half mu square. If the object is initially at rest, u which is equal to what? 0. Then we can modify that equation, W which is equal to half mv square. So this helps to work done in enabling the object to acquire a velocity v after starting from rest has not gone waste and is in fact stored in the body, stored in the object as its kinetic energy. So work stored up in a moving object is called kinetic energy of the body. So that we can say E suffix K, that is kinetic energy, which is equal to half mv square. So we can say that half the product of the mass of the body and the square of the speed of the object, we can say for it. And we can do a numerical based on the kinetic energy. The question is, how fast should a man of 60 kilometer run so that his kinetic energy is 750 joule? So they asked about how fast he should, the velocity, the speed, right? So they have given mass of the body is what? M, which is equal to 60 kilogram. The kinetic energy of the man, which is equal to 750 joule. As we know the formula, kinetic energy, which is equal to half mv square, or we have to modify this base equation because we want to know the speed of the person. How fast should a man? The question is. So V, which is equal to root of 2 ek by m, we will get. By applying all the given value, we will get finally V, which is equal to 5 meter per second. Thank you, children.